All right. I just want to show some quick examples of symmetric and asymmetric encryption. And I'm going to use a couple websites and talk about what they're utilizing for your secure connection. Generally, when you connect to a secure website, you connect in an asymmetric format, and then the session data is sent in a symmetric format as far as the encryption goes. So let's show this now. The first website is PayPal, and what I'm going to do is I'm going to click on the green area here, right on the padlock, and we're going to go to connection, and we'll take a look at that for a second. Now, I'm using the Chrome browser right now, but this method will work the same way or similar to this way on other browsers like Firefox and Internet Explorer and Safari and what have you. You click up here in the green area or where the padlock is. So if we look at the connection, we see that the identity of PayPal has been verified by VeriSign. And VeriSign is a common company to use for certificates. When you make an HTTPS connection, you got to use some type of certificate. And we see other information here, which we'll talk about in just a minute. Remember that we start with an asymmetric key exchange. We're using HTTPS, and that's the standard if you're going to connect to a website where there's a secure connection for some reason. You might be just logging into the site, or you might be dealing with a banking institution or institution like PayPal that primarily deals with money. If it's the latter, you better hope that the website uses the best encryption possible. So HTTPS is going to rely on a secure connection mechanism such as TLS or SSL. TLS is preferable, and in this case, we see down here, the connection is using TLS 1.2. Now, that's not the real encryption being used. We want to know exactly what's being utilized to make the key exchange, and down here we can see it's RSA, and we want to know what the encryption is being used when we actually send session data. We can see here that's AES 256-bit. We can find out more information about this certificate that we've gotten from VeriSign by clicking on certificate information and go into details. And if we scroll down here, we'll see that the public key used during the key exchange is RSA. RSA is an asymmetric algorithm. And we're using the most powerful algorithm that RSA recommends, which is 2048 bits. So that's excellent. We're signing the algorithm with the SHA-1 hashing or cryptographic hashing algorithm. And we don't know exactly what the bit strength of that is, but for SHA-1, I'm going to assume it's 160. We could find that out, but I'm going to assume that's what it is. We'll OK this, and I'll go back for a second. So we know that RSA is being used for the key exchange. So that's the initial connection. And then once that's running, we move over to symmetric encryption. Once the login is finished, we'll move over to symmetric encryption, which is done by AES 256-bit. Very powerful, not known as anything that's not known as crackable, and pretty much one of the best block ciphers that you can use for symmetric transfer of encrypted data. Let's take a look at another website, and we'll go to Amazon. And this is the Amazon sign-in page. Now, if we click on the padlock for this and go to connection, we'll see a little bit more. Again, a VeriSign certificate's being used, but this time the HTTPS connection is TLS 1.0. We are using RSA. If we go to certificate information again, details, we'll see it's the same. It's 2048 bits. And once again, we're using SHA-1 for the hash. And that's very common on most websites. But the difference again, instead of 1.2, we're using TLS 1.0. And finally, for the data session, that's using the symmetric cipher RC4, 128-bit. And it's interesting to see this because some companies have recommended that you don't use this anymore, including Microsoft, for example, for remote desktop services. So it's interesting to see this. It's something to keep in mind. But this is wrapped with the RSA exchange mechanism at 2048-bit. Again, is anybody going to try to grab your information as you're sending it back and forth on Amazon and as a man-in-the-middle attack and try to decrypt that, it's pretty unlikely. And it's also unlikely that they'll be able to crack this. But there is the possibility. So a company like PayPal or your bank or something of that nature, they should use AES, at least 128, and better yet, 256-bit, and the latest TLS possible. So check out your own banking institution and see what it uses when you connect online. You could find out some very important things. Also, check out things like, what's the minimum password length, or excuse me, what's the maximum password length that you can do when you connect to your bank. A lot of banks, they don't go very high. They go to like 12 characters max. So you got to watch out for those types of things. If you do have a limited length on your password with your banking institution online, you better use some complexity. So anyways, let's go to a third website. And actually, just to review, RSA is the asymmetric algorithm. That's the key exchange mechanism that happens first. And AES is the symmetric algorithm, which is used for the rest of the data session. If we go to the NSA website, we see some information here. Suite B cryptography, it's a whole group of protocols that the government will use to secure information on the secret level. And, one of the things they use here is AES on the symmetric side for the sending of data with either key sizes of 128 or 256. Neither of these have been cracked. And oftentimes it's not the protocol that gets cracked. It's the implementation of the protocol, or the protocol is circumvented somehow. For key exchange, the general encryption, going back to this, the general encryption, that's going to be symmetric and quite often AES. The key exchange that initiates all this is going to be asymmetric most of the time. RSA is very common. Here, we're not using that. We're using Diffie-Hellman, but in a elliptic curve format, and that's known as ECDH. If you're doing it in an ephemeral mode, that would also be known as ECDHE, and it shows the length of the curves that are being used as far as the bit length, 256 or 384. Compare that to PayPal that uses RSA with 2048 bits. You need a lot more computational power to do that key exchange with RSA than you do with an elliptic curve with Diffie-Hellman or an elliptic curve with DSA, because the bit length is much less. And finally, they're using SHA as well, and that's going to be either 256 or 384. So pretty powerful stuff. This is in order to get access to secret clearance files. All of these things have to be met. All of these different algorithms have to be met. So you've got your symmetric, you've got your asymmetric, and you've got your cryptographic hash. So that's a little bit about asymmetric and symmetric algorithms. Take a look at some websites. Look at the padlock and check out the certificate information and the encryption used.